Hey everybody, this is Brett from Konecranes. You may have heard about it, you may have read about it, you may have even seen it. I'm talking about the new S-series cranes and this fantastic new synthetic rope. So this thing is just as strong as steel cable. Thousands of hours of testing to make sure that it meets the high standards that everybody expects from Konecranes equipment. This is something that is going to revolutionize the game. No need for lubrication, easy on the reeving. I could go on and on and on. But you're probably sitting there and thinking to yourself, how good is this thing really? And that's what we're here for today. We're going to put this through some real tests to show you just how good it is. Let's find out. Hi, I'm Brett from Konecranes. You know, I know there are some questions out there when it comes to the new synthetic rope from Konecranes and its ability to carry a load. So here's what we're going to do. We're going to do a test over here on the test bench. It's going to test the braking levels of both a synthetic rope as well as the steel cable rope you're used to seeing. I think you're going to be interested in what you see. And now let's meet a member of the test team who's going to be doing the braking strength test. So now what's going on is both ropes are going through the same testing with the same parameters: time, distance, and loading. The steel wire breaks first. Ladies and gentlemen, we have a winner. Synthetic rope beats the steel wire rope. As the old song goes, breaking up is hard to do. At the end of the day, synthetic rope came out ahead. Hi, I'm Brett from Konecranes. We're going to test our new synthetic rope and see how it does when it's put next to grinding and sparks. Let's go meet one of the members of the test team. First, we're going to investigate what the grinding effects are on the synthetic rope from a distance of 50 centimeters. How do the sparks affect the strength of the rope? Let's take a closer look. Is there any impact on the synthetic rope? Nope, undamaged. It's like a new rope. No damage from 50 centimeters distance. Let's do another experiment and see what happens if we grind at close quarters. This is an exceptional situation at factories or workshops, but let's test it anyway. Let's check the result after the sparks hit the synthetic rope. Well, there is some visible damage on the surface of the rope. Now this is going to be interesting. We're going to take this blackened rope, we're going to put it on a test bed to see how it performs. Now things are going to get pretty interesting. We're actually going to go above the nominal load and let's see what happens. It's amazing, the synthetic rope, it's still going strong. That was amazing and crazy. It exceeded the nominal load still and met the safety factor of 5, even though it was subjected to all those sparks in the previous test. It's quite a performance by the synthetic rope. Hi, this is Brett from Konecranes. The purpose of our next test is to show you the durability of the synthetic rope. The test is going to show you what happens when you're using the synthetic rope and lifting a load and it comes into contact with a sharp edge. How does that affect the durability of the rope? And what happens when you're using a steel cable in the exact same situation? The synthetic rope is put at a 90-degree angle with a heavy load. And now the steel wire rope goes through the same sharp edge test. The same load on top of the steel wire rope at a 90-degree angle. And now, the moment of truth. We've got the heavy load and the sharp edge test for both the steel wire rope and the synthetic one. So, let's take a first look at the steel wire rope and how it did with the sharp object test. And the results, well, they don't look so good. If you take a look at the rope here, you can see there are some clear deformities in the cable. That means that it needs to be taken out of action because it doesn't meet the standard inspection criteria. And now, you're probably thinking to yourself, what about the synthetic rope and how did it do? Well, you can see, yeah, there's a little bit of wear on that, but after some standard inspection, we found that none of the strands are broken, and that means that there was no permanent deformation. So it's still good to go. Under the same testing conditions, we saw that the steel cable rope performed significantly worse than the synthetic one. I think the most important thing here, of course, is that regardless of what you're using to lift loads at work, keep it away from sharp edges. Hi, I'm Brett from Konecranes. You know, when it comes to our synthetic rope, one of the questions we get asked most is its ability to carry a load. Basically, how strong is it? But what I can tell you is that this rope is made of premium synthetic fiber. We put it through thousands and thousands of tests to make sure it can carry the load and basically make sure that this is something you can trust with your equipment. And from a safety point of view, one of the most critical things is how the rope fixes to the hoist. One of the members of the test team is going to show you how the splicing for the fixing is done. The splicing is the first and also the most very important phase of the roping. The splicing of the synthetic rope requires less tools than preparing steel wire rope. Now comes the good part. We're going to do a breaking test that's going to show you how strong the splicing of the synthetic rope actually is. And the key here is the splicing. And with the synthetic rope, the splicing makes it far more reliable in the areas where traditional wire cable rope would break down. And usually in the testing conditions, the steel wire rope breaks down at the wedge socket. The synthetic rope is still withstanding this extreme load extremely well. Oh, what a bang! So it's actually worth noting that the synthetic rope, it didn't break because of the splice, because actually the splice is the strongest part of the synthetic rope. Hi everybody, this is Brett from Konecranes. So, why do I have these fancy gloves on? Well, it's chemical test time. We've got some hydrochloric acid, and we're going to test that on our synthetic rope and show how it compares with steel cable rope that you're used to. Let's get to the test. Are you wondering how the ropes reacted to the hydrochloric acid? After 5 hours, you can see that the steel rope is clearly reacting to the acid. You can see the spots. Now it's the synthetic rope's turn. 5 hours of the same treatment. And take a look at that. No visual damage at all. And now we've seen what the acid has done to the outside of both the steel and the synthetic ropes. Let's take a look to see how the acid has affected the strength of those ropes. Okay, so we're taking a look at both ropes here as they're being put under a stress test here on the test bench. Oh, the steel wire breaks first. It's amazing with the synthetic rope. It's actually still not breaking. It's still holding up strong. It's amazing. The synthetic one actually lasted longer than the steel one. That's amazing. There you have it. That's the result of the hydrochloric acid test, and I think the results are pretty clear. If you take a look at the steel wire, there's clear amounts of corrosion there. I wouldn't want to use that in my own sort of factory or setting. Whereas if you take a look at the synthetic rope, you can even immerse it in hydrochloric acid, it's not going to make a difference. So basically the strength is there, still performs as you're used to doing it before. The choice is clear. Which would you use? Hi, I'm Brett from Konecranes. We got a little bit of a bonus test for you here today. So what I have in my hand here is some standard synthetic rope, the kind of thing you get at your local hardware store. You're probably thinking to yourself, looks like the Konecranes synthetic rope. You're going to be surprised. Let's do a load test and see how much it takes before it breaks with WIÍCEJ here.
Thank you.
You're welcome. So there you have it. Now, I'm not going to lie to you, I'm a little bit disappointing. I was kind of hoping this thing was going to go snap and bang and something like that. It didn't do that, but it actually still showed us something that's pretty important. This thing stretched and stretched and stretched, and it didn't break, which, okay, fine, it didn't break, but on the other hand, if you're lifting a heavy load, that thing is still on the ground. That's why you go with the Konecranes synthetic rope.